Hey everyone, Mr. Skelton here. We're back at lesson 7 in unit 4. Today we're going to be talking about solving polynomials by factoring. We've been factoring quite a bit this year already, and that's going to continue today. Again, I want to remind you that we're solving today, so we're trying to get answers like x equals 5 or x equals plus or minus 2. A lot of students have been forgetting to solve and taking it all the way. We've been doing so much factoring that we're leaving our answers in factored form. Make sure that if it asks you to solve, that we're taking it all the way through and actually finding the solutions or the zeros. Okay? So some of the stuff is going to be a review for you, and there's some interesting problems towards the end that are going to be fairly new to you as well. So we'll go through these together. So the first one says solve the following by factoring. The key is given that -3 or x equals -3 is one of the solutions. So we're going to solve by factoring, but what we're going to do prior to is use our synthetic division, okay? And that's going to make life a lot easier instead of trying to factor this. There are some other ways to factor 4-term polynomials, but for right now, we're going to use some of the methods that we've used in the past. So we know that one of the solutions is -3. Again, if you had your graphing calculator, you could plug this in, graph it, find the zeros or one of the zeros, and then use synthetic division. So I'm going to use -3. I have a 1, a -3, a -10, 24. Squiggly line for my remainder. Drop down, that's a 1. -3 would make -6 because we add. That's going to be a +18, which will give me 8. And then -3 and 8 makes -24, gives me 0. Awesome. So what does that mean? It means what we already know, that -3 is a solution. Okay? It also means that we have this left over. This is your constant. That's your x value. That's x squared. So you have x squared minus 6x plus 8. And this is where we're going to do the factoring part of it. So we're going to factor what's left over. What two numbers multiply together give you 8. Add together you get -6. That'd be an x minus 4 and an x minus 2, right? -4 plus -2, -6, -4 times -2 is +8. And we're solving, right? So we're going to set those equal to 0. So that means x equals +4 and x equals +2. And that should make sense. We have 3 solutions because it's x cubed. So we have our 3 solutions there. Why don't you go ahead and hit pause and try number 2, given that a factor is x minus 3. Remember, this is a factor, so it's going to be in parentheses. Okay? Go ahead and try it. Okay. So if x minus 3 is a factor, that means +3 would be the 0, right? X equals 3 would be the solution to this factor, so we're going to test that 0. -2, 15, -22, -15. Again, I'm always checking x cubed, x squared, x constant, so I'm good. My remainder column, drop down -2, -6, 9, 27, 5, +15, and a 0. What does the 0 tell us? It tells us that what we already know, which is 3 is a solution. Now, what do we have left? We have -2x squared plus 9x plus 5. Okay, and we got to factor that. My first thought when I see something like that is I'm going to try and factor this using the box method. So I have, what I would do is times everything by a -1 because I want my leading coefficient to be a positive. So I divide by -1, okay, and that would give me 2x squared minus 9x minus 5. So I would try to box method that real quick to see if I can do it. So I get 2 times -5, which is -10. Let's see. And what two numbers multiply together give you -10. Add together you get -9. That'd be -10 and +1. And so I'm going to have 2x, I'm going to have 1, I'm going to have x, and I'm going to have -5. So I have this factors into x minus 5 and 2x plus 1. And again, we're solving, so that's going to give me x equals 5 and x equals -1/2. So I get 3 solutions there, x cubed, good to go. Okay? All right, turn the page, see what else we got here. Really the same type of question. The reason I want to show you this one is we'll get to it. I'll explain here in a second. Given that 2 is the solution, so again, I'm going to go 2. Check my numbers, x cubed, x squared, constant, or x constant, so I got 1, -2, 1, and -2. Drop down 2, or excuse me, 1. Working too fast here. Drop down to 1. So I got 2 times 1, which is 2, gives me a 0. 2 times 0 is 0. 0 plus 1, 1. 2 times 1, 2, and 0. So again, get a constant, or we get a remainder of 0, which means 2 is a solution. Now, what do we have left? Constant x squared. So we don't have to put 0x. We'll just put x squared plus 1. Now, x squared plus 1, you can't factor that, okay? But it still says to solve. And so what happens here is, if this is set equal to 0, if we subtracted 1 from both sides, we would get x squared equals negative 1. And so we take the square root, and we get x equals plus or minus I. And so we have our 3 solutions. We have x equals 2, and then we have a positive I and a negative I for solutions 2 and 3. Okay? So I want to make sure I showed you that one. All right. Getting down to some special types of, well, let me go back. I just want to make sure, I'm going to go back to the first page real quick. I want to go back to this step when I got this information here, and I have this information here. I want to make a special note that if you like the quadratic formula, you could do that. I know it's solving by factoring, right? And I did factor, I used the box method here, but you may come across a problem where you couldn't factor it. If it didn't factor, we'd have to go back to our quadratic formula, right? Because that's a quadratic because it's x squared. Again, really nothing that we've done so far is anything new. We're just emphasizing the factoring part of it like we did here in 1 and box method here on 2. We're just emphasizing the factoring. Okay, so special types of functions. Sometimes in our algebra careers, we come across some expressions or equations that you have to have some number sense to recognize what you're looking at. For example, this is you've done a bunch of these in Algebra 1. This is called a difference of squares. Difference of squares. And it's short for difference of perfect squares. X squared is a perfect square because of x times x. 4 is a perfect square of 2 times 2. So that gets factored into x plus 2 and x minus 2. Okay? And there's a whole bunch of those. X squared minus 9, 9x squared minus 49, right? That factors into 3x plus 7, 3x minus 7. We just essentially take the square root. And those are patterns. Those are just things you have to recognize. These two examples are also similar in regards to there is a pattern. These are called sum and difference of cubes. Okay? Sum and difference of cubes, which is short for sum and difference of perfect cubes. Just like a perfect square here, 2 times 2 is 4, x times x is x squared. 3 times 3 is 9, 7 times 7, 49. Cubes, right? 8 is a perfect cube because it's 2 cubed. X is a perfect cube because it's x to the third power. 2 times 2 times 2 is 8. 27, 3 cubed, right? 1 is always a perfect cube or a perfect square because of 1 cubed. So if you look at a problem and you recognize that both terms, and if there's just 2 of them, are perfect cubes, there is a formula, and I will give you this. I believe we are going to be giving you these formulas for the sum and difference of cubes. So I'm just going to write it down, and this is something you're going to want to have. Sum means add. Difference means subtract, right? So this problem number 5 is the difference of cubes. This problem here, number 4, is a is a sum of cubes. So what I always do is I always write it as whatever the term is in terms of its I write it as a perfect cube, I guess is what I'm trying to say. X is cubed, 2 is cubed. So here's the formula, a plus b, and then it's a squared minus a times b plus b squared. So my a value is the x, my b value is the 2. And so this would be x plus 2, and then your a value is x, so now it's x squared. A times b would be 2 times x, which would be minus 2x, and then our b value would be plus 4x, or excuse me, just plus 4. Okay? And if you notice on this one, so all we did, this is the formula, and this like I said, we'll give you this, but it's not hard to spend a little time to memorize that. That's called the sum of cubes there. And what we would do then, this is still set equal to 0. Notice that we're still solving these. So anytime it's set equal to 0, we're solving. So we can use the zero product property. That's going to be -2. Should be a bad one. And then you have this. Now, most of us would look at this and say, oh, okay, what two numbers multiply together give you +4? Add together, you get -2. Well, there are none, right? 1 and 4 are the factors of 4, and 2 and 2, and none of those make -2. So I've referenced this about 5 minutes ago. Okay, what are we going to do here? We still got to solve this. So how do we solve this? We're going to have to use quadratic formula. So we're going to have to go x equals -b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. And again, I'm just focused on this. I'm trying to solve that part of it. So that's going to give me x equals 2 plus or minus the square root of, that's going to give me 4. 4 times 1, 6, so minus 16 all over 2. That's going to give me x equals 2 plus or minus the square root of -12 all over 2. Now, -12, we're going to have to break down 12, right? 12 breaks down, first of all, it's -12, so I'm going to put the -1 there, I'm going to put a 4 there and a 3, so I end up getting 2i radical 3. So I get x equals 2 plus or minus 2i radical 3 all over 2. And again, as long as this 2 and this 2, or this term, and that term all have a common factor, which they do of 2, we can reduce the 2 out of everything, so we get x equals 1 plus or minus I radical 3. So you have one solution here, and then you have your plus or minus, which is your second and third solution there. All right. So if you notice here, there's a subtraction sign, so you need the formula for the difference of cubes. It's a minus b, where a and b represent the number that needs to be cubed. So 3 would be your a value here, okay, and 1 would be your b value. And so we have a minus b, and then it's a squared plus a times b plus b squared. So we would have 3x, because your a value, I should have wrote this like this, sorry, 3x cubed. So 3x times 3x times 3x gives you 27x squared. So your a value is 3x minus 1. Your a value is, remember, 3x, so we have 9x squared plus 3x times 1, which is 3x. Then b squared would just be plus 1. Okay? And again, we're solving that, so what does this give us? You would add 1 divided by 3, so you get x equals 1/3. And then again, you're going to have to, you could try to box method this. I'm telling you right now, it's not going to work. So we would do quadratic formula again for this. So we'd go x equals -3 plus or minus the square root of 3 squared minus 4 times a times c, all over 2 times a, which is a 9. So you get -3 plus or minus the square root of, you're going to get 9, basically inside you're going to get 9 minus 36, right? So we're going to get, what, 27? So -27 all over 18, and -3 plus or minus, that's going to be 3i radical 3 over 18, and then I can divide out 3 out of everything, so I get x equals -1 plus or minus I radical 3 all over 6. And those are your other two solutions. Okay? Now, I know that's a lot of work there. I do want to show you an alternative method to doing sum and difference of cubes. So if this was a little overwhelming for you, I'm going to take number 4, and with the space I have here, kind of show you something different, see if this catches your attention. So if I just subtract 8 to the other side, I would get this, right? And I can take the cube root. I know we haven't done a lot of cube rooting, but cube rooting basically means what 3 numbers can multiply together and give you a -8. Now you're thinking, oh, you can't take the square root of a negative number. You're right, you can't, but this is a cube root. So cube root means what times what times what gives you the number inside. Well, -2, -2, and -2 work, so x equals -2. So what we could do then is we could get x equals -2 as our first solution and then use synthetic division here. I could go, okay, -2 and then go x to the third, x squared, x, and then 8. I got to put in my zeros, drop down 1. So -2 times 1 would be -2. Add -2, +4, you get 4. And then you get -8 and you get 0, so you get x squared minus 2x plus 4. Now, you're probably wondering, okay, what's going on? Well, we got -2 as our first solution. Then we got this, which is the same thing as what we got up here in our sum of cubes. My point is, we could use this method. You could use what I highlighted, which is that formula, and plug in things, or you could do what you're comfortable doing and try to find one of the values of x and then just use synthetic division. Now, you would still have to use the quadratic formula there. You'd still have to go down that path, okay? So just wanted to show you an alternative method. If you have questions about that, I can go into more detail in class or re-explain that to you if you'd like to see that, okay? Okay, we're moving here. We're going to try to go a little bit quicker because I know this is a longer video. So here you have, you'll notice degree 4 questions, and there's 3 terms. It's a trinomial, okay? It's quartic because it's degree 4. Anytime I see it, again, this is kind of a number sense. You have to kind of see through the problem a little bit. We're still trying to factor, all right, on these, and so when I look at this problem here, here's in my brain what I really see. I try to see something that I'm used to seeing. You've seen these forever, right? This is a quadratic, and we know that that factors into what 2 numbers multiply together give you 6, add together you get 7. X plus 6, x plus 1, right? 6 times 1 is 6, 6 plus 1 is 7. And that would be correct if I was factoring what I just wrote in pen, but I'm being asked to factor this. Well, it's the same exact problem, except all you have to do when you see these and you see that it's factorable into 2 binomials, we put the square right on the x, okay? And so what we end up getting is this. And so it's set equal to 0, so you're still solving. So what we're going to get is x squared plus 6 equals 0, and x squared plus 1 equals 0. And so if you solve this, you get x squared equals -6, and x squared equals -1, square root, and you get x equals plus or minus I radical 6, and you get x equals plus or minus square root, plus or minus I. And that should make sense to you, because how many solutions should we have? We should have 4. Well, I got a plus and a minus, so there's 1 and 2, and then 3 and 4. Now, some of you may be wondering, okay, I want to see that this makes this appear. So if you just go x squared plus 6 times x squared plus 1, and just FOIL it, x to the 4th plus x squared plus 6x squared plus 6, put your like terms together, x to the 4th plus 7x squared plus 6. So when you FOIL this back out, you get what we started with, which is, again, what we want, okay? All right, so let's take a look at this one again. When I look at this in my brain, I'm thinking, okay, x squared minus 2x minus 8, how does that factor? How does that factor? What 2 numbers multiply together give you -8? Add together, you get 2. X minus 4 and x plus 2, right? -4 times 2, -8, check. -4 plus 2, -2, check. But what do we need to do? We got to put the squares on those x's, and then we're solving these. So x squared minus 4 equals 0, and x squared plus 2 equals 0. So I get x squared equals 4, x squared equals -2, square root, x equals plus or minus 2. So I get 2 real solutions there. Square root, x equals plus or minus 2i. 2 solutions there, okay? The last question is one and the same, so if you want to go ahead and hit pause and try it on your own and see what you come up with. Okay, so again, I'm thinking what 2 numbers multiply together give me 18, add together we get 11, so that'd be x plus 9 and x plus 2. But we got to be careful, don't get too in a hurry. We got the 4's there, so we got to square and square, so that equal to 0. X squared equals -9, I just minus the 9 in my head there. X squared equals -2, I subtracted the 2. square root, I get x equals plus or minus 3i, and x equals plus or minus I radical 2, so square root and square root. Okay? I know that's a long lesson. I apologize for the length, but I wanted to make sure I was detailed and specific on some of that. I'm sure you may have some follow-up questions. If you don't, great. If you do, I look forward to working with you in class. Just let me know, and I'll check in on you in class, okay? Take care.